So on to problem number 20 of the MIT Integration Book of Exam 2017, which is the indefinite integral of cosine x to the power cosine x plus 1 times the tangent of x, all times open bracket 1 plus the natural logarithm of cosine x, close bracket, close bracket. So seemingly long and intimidating problem, but I think it's easy. So let's see how we may be able to solve it. So this is our problem, right? The power cosine of x times 1, tangent of x times 1 plus the natural logarithm of cosine of x. And so this is the same as cosine of x to the power cosine of x times cosine of x coming from this 1 here times tangent of x is the same as sine of x over cosine of x, and we see this would cancel out, and we have natural logarithm 1 plus natural logarithm of cosine of x. Okay, so the problem now condenses to cosine of x to the power of cosine of x times, I want to bring this here first, and there's a reason, cosine of x sine x dx. So like we have now brought our problem to be cosine of x to the power cosine of x times 1 plus natural logarithm of cosine of x times sine x dx. And if we say let u be equal to cosine of x, then that means that du dx is equals to negative sine of x, and so negative du can be used to substitute for sine of x dx. And that's the reason that I shift this sine x onto the other side. So our problem becomes u to the power u times 1 plus the natural logarithm of u negative. So this becomes negative. Okay. So we've come with negative of u to the power u 1 plus natural logarithm of u. How do we proceed? We can do that, and very quickly I think we begin to see something. If you have a problem where y is equals to x to the power x, right? So that means that the natural logarithm of y is equals to x log of x, and the derivative y dy dx is equals to log of x plus x over x, and this is 1 because the natural log of x is, when differentiated, is 1 over x. So in other words, y dy dx is equals to log of x plus 1, and so dy dx is equals to y times log of x plus 1, and so which is x to the x, since y is x to the x, log of x plus 1. So this is important to note. Why? Because since our problem now is negative u1 plus log of u, it means that we have the derivative with respect to u of u here. So when you're an integration is simply an antiderivative. So we're differentiating something and then we're integrating. So what it means is we have negative of u to the power u plus integration constant c. But u was set to cosine x, right? So the integral of cosine of x to the power cosine of x plus 1 times the tangent of x times 1 plus the natural logarithm of cosine of x, yeah, so is equal to negative cosine of x to the power cosine of x plus the integration constant. And that is the answer, ladies and gentlemen. So until next time, I hope you had some fun following along. Bye-bye.